Excuse me?
You're ready to proceed.
Whatever's there is what we got.
Okay.
Good morning and welcome to WNHH-FM's Dateline New Haven. I'm your host, Paul Bass, inviting you to look behind the headlines on the stories that make our community tick. Well, science and regenerative medicine make New Haven tick and grow. And that's why the state's largest scientific conference, StemCONN2020, was supposed to take place this month, right here in town at the Omni. And there's a story behind that story. A different scientific trend, the spread of coronavirus, has postponed that conference, which was scheduled for March 24th, but it won't stop the progress the city has been making of late in the STEM, science, technology, engineering, and math field. Diane Krause is here to tell us all about that. Diane chairs the StemCON 2020 organizing conference. Her day job has a lot of titles. I'm going to read them. Yale Professor of Laboratory Medicine of Cell Biology and of Pathology, Associate Director of the Yale Stem Cell Center, Associate Director of the Transfusion Medicine Service, Medical Director, Clinical Cell Processing Laboratory, Medical Director, Advanced Cell Therapy Laboratory. So the show isn't over. We still got more to talk about, but Diane, welcome.
Thank you so much for having me, Paul.
And listen, you are a busy person, and thanks to Yale New Haven Hospital for providing support for today's program. So reading all those titles, Diane, I get the sense you don't have a lot of downtime. You're a busy person.
No, I have clinical responsibilities for cell therapies, and I am a basic scientist who does stem cell research in my research laboratory.
And I'm going to ask you to get real close to that mic, like you're almost touching it, but not quite.
Okay.
There you go. And so you would have been amazingly busy for the next 2 weeks planning this conference with 500 people like educators, scientists, students, healthcare professionals, academics, state leaders. We're supposed to be gathering at the Omni for this conference on stem cell research.
Yes, in less than 2 weeks, we were supposed to have this conference. We've been working very hard for this.
It's like Comic-Con, right? Yeah. But it's StemCon.
Exactly.
So you're deliberately doing the CONN Connecticut and making a play on how we have these conventions.
Well, it's not just that. It's that the state of Connecticut supported stem cell research, and it's made Connecticut a hub of stem cell research. Mm-hmm. So early in the 2000s, there was a group of us called the Connecticut Stem Cell Coalition, which was academicians from UConn and Yale and Wesleyan, as well as advocates from different disease organizations. And shout out to Milt Wallach, who is a phenomenal organizer, diabetes activist, who really chaired the whole effort to create the legislation in 2005 that Connecticut would be a hub of stem cell research. And that meant that Connecticut also committed $100 million towards stem cell research. And with that investment, we recruited stem cell researchers from all over to build the Yale Stem Cell Center that now has over 95 laboratories that are members of this Yale Stem Cell Center.
All on camp, like all in New Haven?
All in New Haven. Yes. Oh. They were existing Yale laboratories that hadn't previously done stem cell research, that turned to stem cell research because there was funding available and it was an exciting and important new topic. And also because we were able to recruit people here. Valerie Horsley, who was supposed to be here with me today, is one of the scientists who, when she was being recruited all over the country for a faculty position, chose to come to Yale because of the Connecticut stem cell funding that would be available to help her launch her career.
That would have been fun interviewing her. Okay, hope we get her back when she's feeling better. So I guess I'm going which direction first. Let's start with here. What is stem cell research and why should we care about it?
So stem cells are an interesting type of cell. All of our stem cells are one type of cell. And the thing that makes a stem cell unique is that it can make more of itself and differentiate into something. And our bodies have many different types of stem cells. So I have blood stem cells. We all have blood stem cells that make our blood. Those are the ones that can be used therapeutically. We have skin stem cells. That's what Valerie Horsley works on. There are different stem cell populations in the lung and in the muscles. So there are stem cells all throughout the body, and those are what we call adult stem cells. And then the ones that are somewhat controversial are embryonic stem cells, and what made embryonic stem cells controversial is that they came from human embryos, but they ended up being really important for research that we now do with a different cell type that's called an induced pluripotent stem cell. So let me go back one step.
All right.
Embryonic stem cells are unique because they are pluripotent, many potencies. They can become every different cell type in the body. And that's why we really needed to work on embryonic stem cells, because those are the ones we can use in a dish to create any cell type we want.
And we do that to try to cure diseases.
Exactly. For example, there's a guy at Yale, Yibing Chang, who takes embryonic stem cells, which are now, he can use induced pluripotent stem cells instead, and he turns them into heart muscle cells, cardiomyocytes, and he's creating ways of patching an injured heart. He collaborates with biomedical engineers to patch an injured heart so that you can still have a functional heartbeat. Now, those things are not yet ready for clinical trials, but he's getting very close. He's doing those experiments with biomedical engineers at Yale. So there's a lot going on. So
embryonic stem cells, you could do a lot more with them. Is that because embryos aren't fully formed yet? Or?
Yes, because embryos are not yet fully formed. There are cells that can make every cell type. We all start from one cell, the fertilized egg. Then that makes a bunch of cells, and those cells are all pluripotent.
Then they differentiate as
they differentiate during development and go down different pathways. You can kind of think of it as a trunk of a tree and then the branches of a tree. So one branch is going to go towards muscles and bones. One branch is going to go towards your pancreas. One branch is going to go towards your brain. So as they branch out, they lose their ability to become the other thing.
So obviously, for people who have the horror of losing a baby, they can find some kind of positive outcome of that if that embryo is used for stem cell.
No. Let me straighten out there, because that would be a kind of a scary concept out there.
Okay.
If someone loses a baby, that's what happens, and that is not an embryo.
Oh.
That would be a fetus, and we can discuss it here or not. But fetal research did not used to be controversial. It got controversial when people started creating misinformation campaigns about fetuses being sold. And it's never happened, and it won't happen, and it's illegal. But let's take a back step. For embryonic stem cell research, though that research comes from embryonic stem cells, those embryos were all embryos that would have been discarded. And no federal funding has ever been used for that research on those embryos being taken apart and used to make an embryonic stem cell line for the lab. That it's forbidden to use a human embryo in federally funded research.
And is that just because of the power of the anti-abortion movement? They've kind of spread the misinformation. I know you got to tread lightly on that. But
some of it's misinformation, some of it's not misinformation. So the misinformation came from selling fetal parts.
Right.
That never happened, and now there are additional restrictions.
Are they worried about an incentive to
yes, that there would be an incentive for somebody exactly. But nobody's ever been paid to have an abortion, and that's just misinformation. Mm-hmm. But embryonic stem cell research is from people who had in vitro fertilization because they had trouble getting pregnant or had other reasons to have in vitro fertilization, had leftover fertilized embryos in the freezer that were not going to be used to make somebody pregnant and were going to be discarded.
So why would that be controversial? Because that's not interfering with the natural birth process. Right?
Exactly. It's controversial because some people define a human life as starting with fertilization. So if you are someone who sees that fertilized egg as the potential to become a human being, then some people imbue that with all the rights and privileges of a human being, even though they can be discarded legally. They didn't want those used for research.
So whether it's embryonic stem cells or other stem cells, you gave the example of a valve for a heart. What are some other examples? I hear a lot about cancer, but what are the examples of diseases for which cures are being pursued through stem cell research?
Well, the hot one out there, of course, is diabetes, because diabetes is so prevalent in the population. There are two kinds of diabetes. There's type 1 and type 2. And for type 1 diabetes, this often occurs in childhood, and these patients lose all of their pancreatic beta cells, which make insulin, which is necessary to regulate your glucose levels. Too much information.
No, not at all. That's perfect.
That if you could make pancreatic beta cells for those patients, then theoretically you could restore their pancreatic function, and they wouldn't need to take insulin outside their from outside their bodies as a drug. Problem is, even once we make those pancreatic beta cells for those patients, we also have a second huge problem, which is those patients have an autoimmune disease where they actually have an immune response against beta cells. That's why they lost their beta cells. So there are huge amounts of research going on in immunology and in stem cell research to try to address that concern. And there are companies that exist now to make pancreatic beta cells and see if there's a way to at least shield them from the patient's immune system. So that's moving quite rapidly in the company sector. I'd like to mention another one just because it's what we work on in my lab, and so it's near and dear to my heart, and I know it a little better. And that's we're using these induced pluripotent stem cells now to try to make functional parathyroid cells. So the parathyroid is kind of like pancreatic beta cells, but the parathyroid cells make a different hormone that regulates your calcium levels. And patients who become hypopara or hypoparathyroid and can't regulate their calcium levels, that often happens what we call iatrogenically, or in the operating room, when a surgeon, not accidentally, absolutely necessary for the recipient, for the patient, needs to remove the parathyroid glands because they're embedded with a cancer, for example, in thyroid cancer. And when that happens, those patients become hypopara, kind of like a diabetes patient without insulin. These folks are hypopara without parathyroid hormone. And if we can make them some parathyroid cells, they don't have an immune response against their parathyroid cells.
It's fair to say in your lab, you work on developing stem cells that will help in treating thyroid cancer.
No, parathyroid, lack of function of the parathyroid. It's a different thing than the thyroid.
Okay.
But patients who get thyroid cancer, thank you for clarifying that, patients who get thyroid cancer sometimes have to have their parathyroids removed.
Oh, okay.
So we're working on creating a cell therapy for those patients.
All right, and we're talking about that on Dateline New Haven and WNHH FM, your home for community radio at 103.5, live streamed on newhavenindependent.org. We are doing the alternative to what was going to be a 500-person
Let's get back to
gathering
StemCON.
in New Haven at the Omni called StemCON, STEM as in stem cell, all capital CONN as in Connecticut Convention 2020 was going to happen at the Omni Hotel March 24th, I believe it was.
Yes, it was.
And it's not happening because of the coronavirus, but there's still plans for it. So what would have happened at this conference?
So we've had StemCon conferences every other year since 2005, and we really do it for multiple reasons. One is to showcase the incredible stem cell research that's going on in the state of Connecticut. So half of our speakers are always local speakers from the state of Connecticut. We also do it as an educational outreach to high school and college and every other educational level people throughout the state. So had StemCon 2020 occurred on March 24th, we had over 100 high school students from around the country who we are going to be bussed in. We have funds to reach out to these people and bus them to the conference.
Are these kids interested in careers in science research?
They're here to learn about science research and careers in research. We actually had a separate lunch session all about careers in research and careers in biotech. That obviously all of this will occur when we reschedule, but we've got to wait and see, what's going on with COVID-19 before we have a date for when StemCon 2020, maybe StemCon 2021 will occur. But yes, we had over 500 people, at least 100 high school students, and we also have speakers, international speakers, come from around the world to share their expertise with us and really create new links with the Connecticut stem cell research community.
So 3 things, it was going to be one day?
One day, all day. It starts first thing in the morning, goes all the way to the end of the day with meals
showcasing
served.
The research that's being done in stem cells in our state since the early 2000s, when you and others helped get a lot of money invested in Connecticut in this research. You're going to have educational outreach for high school and college students interested in research, and have international speakers share their expertise. So you mentioned 2021. So what do you do next? First of all, you had to have the brakes slammed, right? Because you're probably working like a maniac on this thing.
In fact, some people may be hearing for the first time that StemCon 2020 is canceled because we haven't actually gotten out to all of our sponsors. So we have to, there's just a lot of logistics here. We've got a lot to get.
How do you feel about it after putting all that time in?
Oh, it's a huge disappointment. It's very hard to stop once you're going, 1,000 miles an hour and everything was coming together.
Basketball team, they won 4 straight games in these regional championships. They were going about the state championships.
Exactly.
That's canceled. The plays are canceled. The Yale School of Music concerts. You throw your life into something that matters so much to you and to the world.
Right, and then you just have to stop. It's really the reality of this COVID-19. We know we're doing the right thing. We know we are working towards preventing the spread of this virus, and yet the personal investment has been high, so you don't want to cancel it. Right. It's the right thing to do, and that's why we're doing it.
Bob has a question. Thanks, Bob. Is there any, and thanks for listening to Dateline New Haven, Is there any research on stem cell on dementia or Alzheimer's?
Absolutely. In fact, that's some of the most
question.
interesting research that's going on.
Tell us about that.
And so, as I said, embryonic stem cells or induced pluripotent stem cells, I'd like to just call them iPSC. It's a little easier. So what researchers doing, including researchers at Yale, is they're studying how Alzheimer's forms. And then once they have a model of that, they can test drugs in the Petri dish on what they've grown. So, for example, you can take these iPSC and turn them into neurons that are normally affected in Alzheimer's. And really cool, you can make iPSC from patients who have Alzheimer's disease. So you have.
So those wouldn't be the pluripotent.
They are pluripotent. So if I
thought only embryonic.
I know I didn't quite make my point well.
I'm sorry. This
so
isn't my
embryonic stem cells are pluripotent, and they used to be the only pluripotent stem cells out there. But then, and this already got the Nobel Prize, Shinya Yamanaka figured out how to reprogram normal stem cells, normal adult cells in the body, and make them pluripotent.
And just so our listeners can know, if I understand that correctly, that meant cells that could be all kinds of different kinds of cells, and that's the point of stem cell research, to try to create or replicate cells that can help attack disease in certain ways or challenges in the body.
And cells that can become any cell type
Right.
of body. So for regenerative medicine. So now we don't really need embryonic stem cells as much.
And how did he do that, by the way?
He used his brain and a lot of experiments, which is how we do science. So what they did is they said, what are the proteins that are expressed in an entirely pluripotent cell? What are those that we think are magic? Not magic. What do we think are the most important proteins in that cell that is keeping it pluripotent, in the normal pluripotent cells? And then he narrowed that down to 100 of them. And he said, let me put all 100 of those into an adult cell. And he said, some of those look like embryonic stem cells. Some of those look pluripotent. And he narrowed it down to 20 of those genes. And he got it again. Some of them look like pluripotent stem cells. Long story short, by doing 20 minus 1, 20 times, so different ones, he figured out which 4 were most important.
Oh.
And those 4 genes, we call them OSK and M, just for short. If you put OSK and M into an adult cell that can divide, then you can get induced, because you created them with OSKM, induced pluripotent stem cells, or iPSC.
And back to Bob's question, how is that going to help us deal with
Okay,
Alzheimer's?
so you can take these iPSC and turn them into all of the different cell types in the brain and combine them into what we call like little mini brains. They can't think, incidentally. They're just mini brains. They're like little organoids that have all the cell types interacting in them. And you can see that there are differences in the organoids of a patient when the cells came from a patient with Alzheimer's than if they were organoids made from a healthy donor. And what you end up seeing is the development of these plaques and tangles that are actually part of how we diagnose Alzheimer's.
All right, so you're way beyond my, obviously, my
Then I'm
pay level.
Then I'm doing it wrong.
You're doing it well.
Okay.
And what I'm asking you from that is, so the organoid, the part, the sort of replication of a mini brain of its own there, doesn't think.
No.
But does it produce the cells that will help the brain have memory and think? To
Maybe.
replace the ones that have
We're
been a
not.
problem?
Maybe.
How does it address Alzheimer's?
At this point, we're not talking about putting these cells back in as regenerative medicine for those patients. It's a lovely idea, but that's not where the research that I'm aware of is going.
How are we addressing Alzheimer's?
Drugs that will prevent the formation of those plaques and tangles. So we know that drugs that prevent the buildup of this material
That makes it hard for us to remember.
That makes it hard for us to remember. It can be used once a patient has Alzheimer's. It might slow the progression.
Gotcha.
That's the best we've got. So what about if we can come up with ways of just getting rid of all of that rather than just slowing it? So I think the idea is from the beginning. This is not research I do, but it's research I've heard other people present. The idea is to figure out how to prevent the formation of those.
So before someone gets Alzheimer's,
exactly,
they would use this drug. Now,
yes.
Would they be identified as someone who's at risk of Alzheimer's?
Initially, it will be those patients, and this is my understanding, that initially it will be the patients who we know have the genetic predisposition for early onset Alzheimer's. That's when patients get Alzheimer's in their 40s and 50s. If people, what was the name of the movie, Ask Alice, or the book, What About Alice? Something with Alice. That was somebody who actually had the mutation that causes people to get Alzheimer's early in life.
Yale School of Medicine, where you work, aren't they doing some huge 100-year study on Alzheimer's?
Absolutely. There's a
How
lot
does
of
this
research.
fit into that?
I don't know.
Because you're saying about identifying people, right, who might develop Alzheimer's, and then you get notified if some kind of new development, new cure is developed.
I'm not sure.
Okay. They had a big press conference about that a few months ago, but that's an example of how STEM, science, technology, engineering, is a driver of New Haven's economic renewal.
Right. We can talk about some of
Let's talk about that.
Wonderful science that has taken place in research labs that had stem cell funding that has now gone on to create companies in the state of Connecticut.
And that was part of the idea when you got the state to invest in the research. And we're talking about that on Dateline New Haven and WNHH FM 103.5, live streamed at newhavenindependent.org. We're talking to Diane Krause, who has a whole lot of titles, but let's just say she's a cell researcher and head of labs and a professor at Yale School of Medicine. And she was the organizer of StemCONN2020, the big statewide 500-person conference that was going to take place this month. It's been postponed, but it's not dead. It's just going to have a later life, right?
Right.
All right. So now we talked about all this research going on. How is it translating to jobs and building the economy?
So one of the companies that's been created and from Craig Crew's lab at Yale is called Arvinas, and Arvinas has
ARVENIS.
ARVINAS.
Oops, ARVINAS.
Right. And I didn't look up how many employees they have, but I know they're rapidly growing, and a lot of people who were at Alexion have moved to Arvinas. Alexion being the company that left and went to Boston when they got a new chair. So Arvinas is our new star company that's been growing rapidly in Connecticut. And what they do is they create drugs, new drugs that treat diseases, and they target these drugs to various parts of the cell in a way that they call PROTACs. So that came from Craig Crew's lab. And then another amazing development that came from a biomedical engineering lab at Yale from a guy named Dr. Rong Fan. He created a company called Isoplexis. I'm sure he's creating other companies as well because he's brilliant and amazing. But if people have heard about specialized single cell research, that's a hot topic. So he came up with a way, because he's a biomedical engineer, of studying what single cells produce and measuring that. And that's already being used by clinical laboratories that do CAR T cells, the hot new CAR T cell immunotherapy. The companies that do CAR T cells are sending samples to Isoplexis to learn better how their cells are functioning so that they can improve their therapies so that we have CAR T against more and more diseases.
All right, so that'd be two examples, but there are a lot of examples. And aren't we even running out of lab space? There's a plan afoot now to build a second tower across from Alexion. I believe that's an 11th-floor tower, if I'm not mistaken, 100 College Street. Now they're building 101 College Street, where we're filling in the old Route 34 connector in between the hill and downtown. And why are we running out of this space? How many companies, do you know how many we're hatching?
I am not aware of that, but I know at Yale School of Medicine we are desperately in need of more lab space and are taking up some of what used to be the Alexion building in order to expand our neuroscience research institute.
We got a lot of state aid, Alexion, to build that tower, but then they abandoned half the place to send their jobs to Boston, but you guys came and filled it up with the Yale School of Medicine, so that's still filling, still paying taxes. You're a listener asking about stem cell research for sickle cell. Is stem cell used in sickle cell?
Oh, that's such a great question.
Thank you, Bob.
So sickle cell anemia is an anemia where you don't have enough erythroid cells circulating. Actually, you don't have erythroid cells that are carrying oxygen because they sickle, and they cause acute pain crises and a lot of problems in these patients.
Disproportionately hits the African American community.
Absolutely. And we know the mutations that cause sickle cell anemia. In other words, we know exactly what's wrong with the genes that cause sickle cell anemia. And in patients who have sickle cell anemia, if they have a matched sibling, if they have a brother or sister who matches them immunologically, we can do a bone marrow transplant, which is a form of stem cell therapy, and they will be cured. It's not a safe procedure. There are a lot of complications associated with bone marrow transplantation. So in a patient who is severely affected with sickle cell, they're young, they're having strokes and too many pain crises, and if they have a matched sibling, we can do a bone marrow transplant or a stem cell transplant on those patients. We do it routinely at Yale and elsewhere. But what about if there was a way to fix the patient's own cells? So then it's not so dangerous to do the transplant. The danger of these transplants is all the you have to immunosuppress the recipient. But if you could fix the patient's own cells, and this is what Andrew Brock, who was supposed to be one of our Andrew Bauer, who was supposed to be one of our speakers at StemCon and will be when we have it next year, he's doing this up in Boston. So it's a combination of stem cell therapy and gene therapy, where you take the patient's own cells. The patients have sickle cell anemia, take their cells out of their bone marrow with a needle. You fix the gene that's broken, that's mutated, and then you put those cells back in, and the fixed cells take over for the mutant cells, and the patient no longer has the symptoms of sickle cell anemia. And there are also companies that are coming up with ways of doing this, because even though different mutations cause sickle cell anemia, every patient could be fixed if we could just turn on a different gene, this sister gene, this BCL11A that turns on other. So the people have sickle cell anemia because they have a mutant globin gene. It ends up, we have a fetal globin gene that's normally turned off. And if you can turn that gene back on, the patients are cured. Oh. So there are drug companies out there biotech companies doing a combination cell and gene therapy, stem cell and gene therapy, where they just turn on that fetal hemoglobin. And those patients have been in the news from the clinical trials. They're doing very, very well.
Any of that happening in New Haven?
I don't think that specifically is happening in New Haven, although there are people working on gene therapy developments. There's a great lab, Peter Glazer's lab, that has done that in mice with a novel way of fixing the mutant gene that we hope will also get to clinical trials. It's a different approach, but that's what Peter Glazer is doing.
Diane, how'd you get involved in this? Did you grow up wanting to be a science researcher?
That's a really good
cure
question.
Diseases? What did you grow up wanting to be, and where did you grow up?
I grew up in Pittsburgh, Pennsylvania. I always loved science, so I think I kind of assumed I would get a PhD in some kind of a science. And
you
then
assumed that at 16 years old?
Probably in high school, I already knew science was my favorite subject. I didn't really know how I was going to do it. My father was a physician, and I knew I didn't want to be a primary care physician. It's not a bad thing to be. It just wasn't right for me. He was a cardiologist. So when I went to college, I majored in art history and biology.
That's interesting.
Yeah, and a lot of scientists.
And you must have really loved. I love the kind of microscopic designs when you look at the microscope and you see the makeup of cells. Exactly. They look so beautiful. I remember that in ninth grade biology. I thought mitochondria were so cool. Exactly.
So you just look at something and you say, that's what interests me. So long story short, I learned about the MD PhD, a combined program where you do med school and a PhD. And that is what really appealed to me, because I wanted my research to have something to do with treating patients. And I thought, well, if I get an MD and a PhD, then I'll know what doctors know, and I'll be able to have my science affect them.
And that's so interesting. And unlike your dad, going to see the patients, you're helping people like your dad cure the patients.
Exactly. And so nice. I am in clinical pathology, laboratory medicine at Yale University, where I'm basically behind the scenes helping to take care of patients, and then my research lab. And what we do in my clinical pathology, with my clinical pathology hat, is process all the cells for bone marrow transplantation. So those are stem cells. So when I thought about it, I thought, well, how do those cells work? When a patient gets a bone marrow transplant, we just take cells that were in the marrow of somebody else, and we put them in the peripheral blood of the patient, and they go back to the marrow, and they set up shop, and they remake all of the blood for the rest of their lives. And that blows me away even now. And I thought, well, that's what I want to work on. So I work on those stem cells and how they function in the marrow to make all of our blood cells, how they make our platelets and our red blood cells.
How did you get to Yale, Diane?
I completed my MD PhD at University of Pennsylvania and did a postdoc at Johns Hopkins. And then I was looking for jobs, and this is before there was the internet was the way you did everything. So it was in 1994. I sent out a bunch of letters to places saying, hey, I have an MD PhD. I want to work in bone marrow transplantation and do my research on how blood forms. And Yale was one of 4 places that made me an offer, and it was where I wanted to come.
You settled here, and as you said at the beginning of the show, around 2000, around 20 years ago, right?
Right.
You emerged at the forefront of an effort to get dramatically more state investment in stem cell research, and you've helped lead Yale and New Haven to the forefront of this work. And
it was very frustrating at first to be the only person, or one of 2 people at the time actually at Yale, who identified myself as a stem cell researcher. It was really just not a field we talked about. It was part of what other fields.
How many do we have now?
Now we have at least 95 labs at Yale. We have, I wrote it down. At Yale, we have more than 150 scientists across the state, 150 laboratories across the state. So that's not just Yale. Yale, UConn, and Wesleyan, over 150 laboratories are working in stem cell research, and they employ over 600 individuals. So this is a large group of people working on stem cell research throughout the state, at UConn, both campuses, at Yale, both campuses, at Wesleyan, and also we have outreach to Eastern Connecticut State, Southern,
So you also
et cetera.
came here at an interesting time. You came in 94 when Yale made a 180-degree turn in the concept of using scientific research as a driver of commercial work. So Bart Giamatti was the president of Yale when I was a student there, late 70s, early 80s. Very idealistic man. And he felt that you should not poison academic research, in his view, by having any kind of commercial connection, because that will steer the inquiry toward the desires and demands of commerce and the market rather than the pure search for knowledge. And so when we started Science Park during his tenure, but he was very reluctant. Yale didn't put a lot into it as a place to take the old gun factory that was gone to try to build the jobs of the future. We had some companies, they tended to leave as soon as they were ready to make anything, like the stick it in your thermometer started here. They got built in San Diego. But then Rick Levin came in and the Office of Cooperative Research started at Yale. And they decided part of how we're going to help New Haven grow and help Yale grow is to use the marketplace and all these discoveries we make to create drugs and other products that will make society better in their view, and they believe the market could be an engine for that. And then they jumped all the way in. And Science Park's all filled up pretty much. Building 25's all filled up. Then we got 300 George Street got all filled up, the Alexion building, and we're running out of space. And so you watched that turn. You were there at the birth of that in 94. Did you wrestle with those same questions? Did you see a change in the labs you worked in, the conferences you went to, where there was more of a confidence in the marketplace to steer research where it needs to go?
It's a good question. I don't think that there's a conflict anywhere. I don't think it's actually changed people's research. I think people always wanted to do some people always wanted their research to have applications in the market, applications to patients, and some people are very, very motivated to do the most basic of research. And it's all incredibly important. And it's not just for commercialization. It's rarely just for commercialization. If there's a commercialization application, absolutely, we should take advantage of that.
And obviously that gets you a lot more money for the research as well, because it's not just
there's
government
nothing wrong
money.
with it, but I don't think it changes people's focus.
I don't think I think Giamatti was well-intentioned. I don't think there's anyone making his case anymore.
Right. Yeah, I think that might have been, he came from the right place where he worried that it might steer people away from their basic science, but I don't think that it actually did. I think people who love to commercialize ideas were probably those people anyway, and now they can be highly successful doing it. And those people who want to be in their laboratory and discover novel mechanisms for how a cell knows to do what it does, those people will continue to do that.
And if we prevent sickle cell anemia.
Exactly. That's right.
All right. So StemCon, are we definitely off for 2020, or it might take place later this year? You're going to go 2021?
Well, we would love to have it in the fall. We haven't decided is the answer. We would love to have it in the fall, but that tends to be an incredibly busy time with a lot of conventions in academia. So my suspicion is we're looking at next March 2021, but I don't know for sure. So to be determined.
Because aren't people saying that we might get a second wave of the coronavirus?
If it's anything like the Spanish flu in 1918, that's what happened. Is it seemed to get that a lot fewer people got it over the summer. It was a different kind of virus. A lot fewer people got it over the summer, and then there was a resurgence in the fall because it's like the flu. So we don't know if that's going to be true for this coronavirus.
Besides having to put a break on your conference, which we're glad is still going to happen, and we're going to give it lots of coverage when it does. This virus outbreak, how else has it affected your life? How is your life different? Is the work going on at your lab?
We're just in the process of figuring out how to keep ourselves away from one another and continue to do our work. So we're having a lot of meetings to figure out the best way to do that. We're figuring out so much of research. People sometimes think people in the research are loners, and that's not true at all. So much of what we do is dependent on our interactions with others and discussions with others, some of which you can do online and on the phone, but a lot of which you do in person with meetings. So we're having fewer meetings with large numbers of people, and we're trying to maybe stagger when people come into the laboratory so that they're not working right next to each other in order to slow the spread.
Fewer meetings, smaller meetings.
Fewer meetings, smaller meetings.
Staggered work schedules.
Yep.
But you still got to show up. You can't do this all remotely.
Exactly.
All right. Boy, I learned so much today.
Thank you very much for having me.
And I'm so glad you're in New Haven. I'm so glad you're doing so much great work
Thank
to
you for
try
having
to
me.
help us
Appreciate it.
tackle arthritis and, Alzheimer's and diabetes and sickle cell, Parkinson's.
Yeah.
Well, keep up the good work.
Thank you so much.
And we're not gonna forget the need for it when it's StemCON 2021.
Thank you so much.
All right, thanks for joining us today on Dateline New Haven. Thanks to our guest, Diane Krause. Thanks to the miracle man behind the controls, WNHA station manager Harry Dross. And thanks to Yale New Haven Hospital providing support. We're going to take it out with the Afro-Semitic Experience, performing I Wish I Knew How It Would Feel to Be Free from the group CD, A Plea for Peace. This is Paul Bass inviting you to fly free with us all day and all night at WNHH, New Haven's home for community radio.